Hi everybody! So we've seen a lot of reactions, so I think it's now time to classify them. So the first reaction we will talk about is combustion. Combustion is a reaction of a substance with oxygen gas, typically, or any other oxidant, and these reactions need heat to start, but once they start to react, these reactions release a lot of heat, and this heat provides the energy needed for the reaction to continue. So it is a self-sustaining reaction, meaning that once you start it, it will keep on going and going and going until your fuel or whatever is reacting with the oxygen runs out. So let's look at some examples. So if you have a compound with carbon and hydrogen at the bare minimum, then you will produce carbon dioxide and water in their gaseous forms, since under high temperatures, such as those in combustion reactions, the water will typically evaporate into water vapor, the gaseous form of water. So, for example, if you combust methane with oxygen gas, you will produce CO2 and H2O. And in the same way, if you burn CH4O, which is methanol, with oxygen gas, then it will also produce carbon dioxide and water. Now, what if you were burning a substance that only contained carbon and not hydrogen? Well, if you don't have hydrogen, then if you are something like just elemental carbon and you react with oxygen gas, then you will only produce carbon dioxide and not water. And the reason why you don't produce water is because the carbon does not have any hydrogens, and therefore your products cannot have any hydrogens in it either. So that's why we don't have water on the right-hand side, since our left-hand side didn't have any hydrogens. And for the same way, if you make carbon monoxide undergo combustion, it will only produce carbon dioxide gas, simply because there's no hydrogens on the left-hand side to produce water on the right-hand side. So now what if we tried burning things that had different elements? For example, if we tried burning nitrogen gas with oxygen gas, well, simply they will just combine and they will form nitrogen monoxide or nitrogen dioxide or any other nitrogen oxide. So what if we tried combusting sulfur solid? So if we tried combusting sulfur with oxygen gas, then we would just get a combination of the two, or sulfur dioxide. So notice how the element that is being combusted, or the compound that's being combusted, is reflected in the products. So if you have nitrogen being combusted, your product will most likely have nitrogen atoms in it. And remember, the most important thing about combustion reactions are that it occurs with typically oxygen gas. So notice how for all these, they are all reacting with oxygen gas. So that's a clear giveaway that it's a combustion reaction. Now let's move on to our next type of reaction. They are called synthesis or combination reactions. This happens when you combine two or more substances. So we've looked at combustion reactions, and some of these are actually synthesis reactions as well. For example, N2 plus O2 forming NO gas is a synthesis reaction because you are combining two or more substances to form one substance. And notice how I'm not balancing any of these, because you don't have to have balanced reactions in order to describe what's happening. You only use balanced reactions when you want to know what exactly is happening, and we just want to know like the general overview, so that's why we're not balancing them just yet. So this is a combination reaction. Let's look at another combination reaction. If we combined sodium metal and chlorine gas, then we would get sodium chloride, which is a salt. And this is another example of a combination reaction because we have two or more substances being combined into one. Now let's look at our third type of reaction, which is the opposite of a synthesis reaction. This is when a substance breaks down into different substances. So for example, if we broke down calcium carbonate, we would get calcium oxide and carbon dioxide. This is a decomposition because you are breaking down one substance to form two substances. Another example of a decomposition reaction would be the decomposition of water into its elemental forms, hydrogen gas and oxygen gas. And let me put these in their right forms. So that's a solid, and that's a gas. Now, I just wanted to add something about combustion reactions. So this is a very common example of a combustion reaction. In the picture, you see wood being burned, and this usually happens during combustion reactions when you have compounds that contain carbon, hydrogen, and oxygen, such as those found in wood, and when they burn, they react with oxygen gas, and they typically produce carbon dioxide and water. So what you're seeing here is the combustion or burning of wood, which releases carbon dioxide and water, and in addition, it releases light energy, which is seen by the fire, because, the fire that we see is simply just a form of light, and also releases some heat, too. So this has to do with, the conservation of energy, which states that energy can neither be destroyed nor created, and it can only be converted. So in this example, in a combustion reaction, the atoms rearrange to form carbon dioxide and water, but as they rearrange, the chemical energy in the bonds are broken, and then there's a net release of energy, and this chemical energy that are in the bonds are transformed into light energy and heat. And that's how a fire works, and that's how combustion works for the most part. So that's all for this video, and have a nice day.